understanding what all those variables do is it all links up to like the standard form or like the standard graph. I mean, they're referring to it here as the mother graph, which is like, okay, that's interesting. So with the information that we have right here, they're saying explain briefly the parameters A, B, P, and Q. Explain briefly how the parameters A, B, P, and Q change the mother graph. So whatever we're gonna do here, if you need any more, if you maybe need like a second look at what we're going to discuss now, you will be able to find that in the trigonometry playlist. Because in the trigonometry playlist, it's basically going to showcase what we're actually going to showcase just now. But obviously, you will have it like separate where, yeah, it's going to seem a bit repetitive, but then I think it's going to like help solidify the idea of what A does, what B does, what P and what Q does over there. Because if I go to trigonometry revision, is it under revision? Yeah, down here, you see, it says trigonometry sine graph explained, trigonometry cos graph explained, trigonometry tan graph, and the different variables of our graph are basically also showcased here. But I think let me not waste time by like showcasing this because I don't like, you can always look at that whenever. So here, for example, to start off, what we need to understand is things like what the standard graph even looks like. Because as long as you know what the standard graph looks like, you're always going to be able to link up the picture with the equation later on with like other cases where your values of A, P, B, and Q would have been changed. So to start off, right, anytime you are dealing with like a plain equation of a graph, you'll have, for example, this and this, right? Like y is equal to sine x. What you want to recognize is y is equal to sine x is a specific equation. It's a specific equation where you want to recognize that here you technically have the number 1 in front there. And then directly next to what you call x, you have your value of what you may call it. But here this is like, this is like a different setup. Wow. Okay, so we don't have to do what I'm about to do right now, because we can just make use of the criteria that were given here. So we can already see that where A is, we know that because there's nothing over here, it means that the number there is just a 1. And then directly next to the sign, you can see here, the only issue I have with things like this, right, is that, there are no brackets there, of which anytime you have a sign, automatically you have to put brackets over there. And then since there's nothing after the x there, it means that the value there is just a 0. Inside here, you can see we have an x, right? Now, the funny thing is that with what they have here, right, directly next to x, because we don't have anything in our equation for sine, it means that whatever is next to x here is just a 0. So the p there is a 0. And we're going to also explain what p is and what q is, and also what our value for b is over there. So the value for b, in my honest opinion, I think the value for b here is the one that's just a bit off, because I mean, like the way it is, it's not very natural, because most of the time, if we're going to be talking about variables for a trig graph, we're going to have something like this, where it's like a and then the trig ratio. Here we have a b value, which is going to be telling us the frequency, and then plus q. So this is the denominator. That's almost, I don't know, it just looks a bit weird, because even in like textbooks and all that, well, you would hardly ever bump into anything like what we are seeing in that expression over there. So to just give an idea of what I mean, if we, for example, open like a grade 11 textbook, right, and we maybe go to like the trigonometry section where like trig graphs are like being revised and all that. Let's actually just do that so that we can paint a better picture with regard to what we need to do now. So trigonometry, that's like page 135. Just scroll down here. Let's see, yeah. Thing is taking its sweet time. Let's see, 135. Okay, this is 155. And then 135 should be somewhere here, 135. There we go. So if we go on to where we start talking about trig graphs, let's see where that is. Not here. Okay, almost here. This is the reduction formula. We want specifically trig graphs. Let's see here. Trig equations. Okay, trig equations, blah, blah, blah. Trigonometry equations, general solution. No, that's not exactly what we want. Let's see here. It says here trigonometric equation of the form a sine theta, blah, blah, blah. Okay, I think we're kind of close now. And then let's see, trigonometric equation with identities are invalid. Okay, let's see here. Solving trigonometry equations without the calculator. Solution of triangles. Okay, this thing, let's keep scrolling here and see how far we can get. More triangles, more triangles. Let me just maybe scroll a bit more. Okay, finally here we have like trig functions, right? Now, if you look at this format, you see, there is a value of a here, and then there's a value of q over there. Furthermore, let's see where I saw something about frequency somewhere here. Okay, not yet. Maybe that's like later on. Okay, period shifts. And then let's see what we have here. Divisions, conclusion, yada, yada, yada. I think from here, rules of sketching the graphs in the form this. So you can see where the B is here. Do you see that the moment they're talking about a value of B, do you see it's directly next to X and not like under X? Because the value directly next to X here, that refers to the frequency, you see, of which your frequency always has a formula. Oh, here the word mother graph is coming again. So it says the period of the graph, blah, 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 blah. Let me just, okay, let me write it out, right? Like for our value of B here, the way it would be here, our value of B, which is the frequency, would just be like 360 over the period. You see, this is like a formula of which the value of B here is frequency. You see, that's like the norm. And then if we scroll down a bit more here, okay, we have like some examples, some more examples. I think if we can get up, there we go. No. So here it's the rules of sketching a graph in the form. So here you see they've introduced the p-value, which we're also going to discuss just now. And then if we keep going, okay, no, I think the moment we see more challenges, it means that it is done. You see, so from all that we can see here, the one thing I'm trying to emphasize is that our value of B is always going to be directly next to X. So the moment we see that it is not directly next to X and we have like something at the denominator here, I mean, that's almost like a totally different ball game. So the one thing that I would maybe even want to check is like the previous questions to see if the previous questions have anything to do with why they're asking this question in this manner. Not to say that it's just like, you know, too absurd, but then I mean, you know, we just need to know the previous questions. Okay, so there's a question before this as well that we also would need to consider, because if you look here, right, you see here it says therefore in y is equal to this over that, or y is equal to sine this of b, changes the what and the what remains the same. So what did you put down for these two spaces here?
Okay. So maybe. So I said that B changes the period and amplitude remains the same.
You said b changes the period and then the amplitude stays the same.
Yes.
Yeah, that's actually quite accurate, because with where B is here, in this example, okay, I'll open it just now, because where B is, it does not affect our amplitude at all. So the amplitude would remain the same, regardless of image that we would be seeing here. Yeah, so I think this one is the one that comes before the C here, because here it says you have it says here draw the let me move this down, because what we have here, right, this starts off by asking us to do the following. It says draw the graphs of this. Yes, we drew them, I'm assuming. And then down here, let's see, complete the following statements, right? In the general, in general, the amplitude of this is equal to, well, A is the amplitude.
Oh, yeah.
Yeah, so A is usually equal to 1. Because if we say use the graph to fill in the following table. Well, amplitude here, I mean, it's the value there. So this one, amplitude is 1, amplitude is 2, amplitude is also a 2 here. Because amplitude can't be a negative number, because amplitude is basically distance. Yeah, and then the period here, you can get it from your formula. Remember, the period is always the number in front here of x. You're going to say it should be equal to 360 over the period. So solving for p here, p is 360. You see, because if you multiply by p on both sides, you're gonna have p is equal to 360. You see?
Yes.
Yeah, if you're trying to solve for p. Here, your period is also going to be 360, because your frequency here is still a 1. So here it's still 360. And then here, the number here is still a 1. So this will still come out as 360. And then here it says, in general, the amplitude of y is equal to a sine x is equal to a. And the period of y is equal to a sine x is equal to 360. The period here is based on the number directly next to x over here. And this number will give us our amplitude as long as there's no horizontal, as long as there's no vertical shift, like going up or down, you see. And then, or even if there is, it'll still give us our amplitude. And then it says, therefore, y is equal to this in, y is equal to this, or in y is equal to cos x, a changes the amplitude. So this amplitude, I think yesterday when you were talking about trigonometry, I don't know why I didn't mention the playlist, like, a changes the amplitude, and dash doesn't change. And yeah, you can say period doesn't change here. That's still accurate as well. Then it says that the graphs of this, let's see, cos x divided by 2 for x is equal to 0 to 360 on the same set of x's. Here it says, oh, you need to draw these graphs. Okay, so I'm assuming you drew them. And then it says the amplitude, I mean, like, amplitude here is just a 1. Amplitude here is just a 1. The amplitude here, this one here, I don't know if this is a typo.
Yeah, no, it's not. It's not a typo. It's x.
Okay, so this is just a straight line. So this is just a straight line graph.
No.
Because y is equal to x over 2 is the same as y is equal to a half x. Yeah, so what I'm saying is, was there maybe supposed to be like a sign in front here or a cos in front
cos.
there?
There is a cos. It's y is equal to cos x over 2.
Oh, so they forgot to put it there.
Yeah, because I just like saw from like when it says draw graphs of y is equal to cos x.
Oh yeah, okay, yeah. So when they were writing it down here, okay, maybe they forgot it. So this should be like y is equal to cos x over 2. So x over 2, I mean, the number in front of the cos there is still a 1. So we would want to keep in mind that our amplitude is not the affected. However, the period now is definitely affected, because what you want to be seeing here is cos, the frequency is now a half. Now, frequency tells you how many complete graphs you see in a space of 360. So have a graph, you're going to see it in 360. So in 720, you're going to see a full graph. But to make it easy, your formula, remember, is just frequency. Let's say frequency here is equal to 360 over the period. This is for sine and the cos graph. For 10, the 360 is just 180. So here you can see frequency is a half. You can have 360 here over period. And then here you can just cross multiply. P times 1 is P. 2 times 360 is 720. Do you see it?
Yes.
Yeah. And then here we say the period would still just be 3. Oh, no. Here, not the period won't be 360.
It's 180.
The frequency, yeah, the frequency there is a 2. So we would get a period of 180, as you say, because in a space of 360, there's 2 graphs. So 360 divided by 2 will give you 180, of which your formula would have still given you the 180, because if there's a 2 here, it would be P times 2, which is 2P, and then you divide by 2 on both sides. So that's perfect. Now we're here. Complete the following. In general, the amplitude of y is equal to this is equal to 1. And the period is equal to, I mean, there's a B over there. So technically our frequency is like 1 over B. And then we have 360 over the period. So the period is going to be equal to, let's see if we were to cross multiply here. P times 1 is like P. Our period here is going to be 360B. If whatever B is, because B, whatever B is, it's going to affect the period. Do you see?
Yeah, sorry.
Yeah, we just threw it into this formula. Now here it says, therefore, in y is equal to this, or y is equal to this, B, we can see that B changes the period. B changes the period, and dash remains the same, and amplitude remains the same, if we can put it that way. Amplitude remains the same, because amplitude is affected by whatever is out there. Drawing these graphs, that would be fine, because this one has just moved 2 up, 1 down. Okay, so the shifting here, I don't think you mentioned anything about that. Now we would be down here now. It says, briefly explain how these parameters change the mother graph. Okay, so what we can already say is we can speak of each of them individually now, you see, because of what we have just realized from what we were doing. So A, changes the amplitude of, we can use their words, of the mother graph. Okay, that's going to be the first mark, because I think they had given us 4 lines there. And then here B affects, let's use different words. B affects the is that how you say affects? Yes, affects the period, and then here P shifts the graph horizontally, which is from left to right, horizontally. And then Q shifts the graph vertically. Q shifts the graph vertically. And there we go, right? There we go. Oh, what time? Yeah, there we go. It shifts the graph vertically. Oh, today is the 17th. Interesting. Oh, wait. Oh, all right. Oh, yeah. So, yeah, we can carry on.
Okay. And then I have a question on D, 11D.
11D. Is it this one?
Yeah.
Yeah, let's go.
No, that's 5D. 11D is
Oh,
the one with the total mark.
the one with the total mark. Oh, yeah, I remember it. Probably like one of the last images then.
Second last.
Let's see here. Modified. Where's this thing here? Lab. Okay, my guess is this one. Ah, nice guess. Let's see. So 11D, let's do this. Plan is still to prosper. You have not forgotten us. You're with us. Oh yeah, there we go. So as we're looking at this, right? It says 11D, you had a question. Okay, yeah. So the good news is, right, on the functions and graphs course, you're
Okay.
going to bump into a lot of questions like these. You see, because pardon?
No, I have to what do you call? Okay. Sorry, never mind.
Cool stuff. For which values of x, right, where x is between 0 and 360. So there's 0 here and 360, right? They're asking for which values of x will this minus this equal a 4, this minus this equal 2, this. Yeah, so the easiest way to look at these questions is, remember, anytime you see something like g of x or f of x, it's just representing the y values of those graphs, you see. So it's literally just the distance between the y values at a specific spot. Like, for example, the distance between the y values here is like a 2. The distance between the y values here is like a 1. The distance between the y values here is 3. The distance between the y values here is like 4. You see it?
Yes.
Yeah. So with our questions, that's literally what all they want us to look for. They want us to look for the x values where the distance is a 4, where the distance is a 2, where the distance is a 3. Because look, all this is saying is you're going to have to take the y value of one graph, compare it to the other one. You know, that's, remember, remember minus means difference. So this is asking the difference between this y value and this y value. The difference between these two y values, the difference between those two y values. This question is asking where is the difference between the two y values equal to 4 units. So 4 units, we saw it was here. This is a spot where the distance is 4 units. And the x value there is 180. You see, so that's the answer for 180. We also have to look for any other spots where you have a distance of 4, and we don't have it, you see. Here, where is the distance equal to 2? The distance is equal to 2 in 2 places, you see. There's now, what did I do now? Go back here. Oh, there we go. So there's this, let me put it in red. Come on, go. And then, okay, let's do, oh, no. There's 2 units there. There's 2 units there. So, and that's where x is a 0, or where x is a 360. You see it?
Yeah, that's one.
Yeah. And then the last one is asking where the distance is a 3, of which that's where x is
270.
270. Yeah, 270. Yes, madam, it is 270. So with let me see here. Oh yeah, so where is this thing now? What did I need to do? Oh, oh, I forgot to give the answer. X is equal to 270. There we go. And then what would be next? Yeah, from here, yeah, that's that for those questions there.
Yeah. Yeah, that's
Nice. You're saying that's all?
yeah.
Okay. Let me maybe stop this one here. I don't know if we said anything that was